So quadratic functions and graphs. We start with just looking at x and f of x. Now, some of us see f of x and we freak out because it's not a y. It's the same thing. Okay? When we talk function notation, we usually put f of x, but we can put different letters there. It's the same thing as graphing with y. So I'll pick some x values to start. And so I'm going to take whatever x values I have, plug them in, and square it to get f of x, which is x squared. Now, what are all of those values going to be after I square them?
Negatives and positives. 2 negatives and 2 positives. So 4, 1, 0, negative 4. I mean, 1 and 4.
Okay. Are they all positive?
No.
Yeah.
They're not. They're not what?
Negative.
Not negative. They're not negative. So we go to graph these points. We say they're not negative, so when I graph it, I'm going to have nothing below the x-axis. Everything is going to be above. So I have our points -2, +4, -1, +1, 0, 0, 1, 1, and 2, 4. Now, sometimes we see values like 1/2. Just to make sure we're paying attention. What is 1/2 squared?
1/4.
Yes, it is 1/4. It is not 1. That would be 1/2 plus 1/2. It should be 1/4. Which we could even plot that if we went over 1/2 and up 1/4. That would be about right there. Now, if we kept going, the graph would continue to get bigger as the values get further away from 0, and it gets steeper. What do we call this graph?
A V.
Positive.
There you go, a parabola.
Oh.
If I plugged in 3, where would I go? What's f of x if I plugged in 3?
9.
Be 9. If I plugged in 4?
16.
Yeah, it keeps going from there. So it gets very steep as it begins to go up. And the actual place that it's at, the shallowest, it starts out kind of shallow, it goes to 1, jumps to 4, I mean that went up 3 units. Then as I go to 9, it's going to go up 5. As I go to 16, it keeps jumping more and more. It gets very steep as it goes up. Usually we just draw the first 2 to 3 values out just to get the general idea of the shape. So, parabola. Parabola is not linear. It's going to show up when we have an x squared.
So as the line gets more steep, does it end up going up like this? Like,
It doesn't get vertical. It continues to go out, and it keeps expanding. It just does it very slowly. Because I could always plug in another x value that would be further out. So if I came all the way out here to like 10,
that's 100.
it'd be 100. So it's way up there. So it took a while to get to it, but it does keep slowly growing out as it goes. It doesn't curve back around. That's a little bit different than we want. All right, so now we got some terms. Let me steal our graph here. Okay, the vertex. What is a vertex in this?
When is vertex?
0, 0.
Okay, so we call it a center. In this case, it's 0, 0. Is it always 0, 0 though, with any
No.
parabola?
No.
How would you describe it though?
The
Origin.
pointy part.
Pointy part? Like that? Okay, now what is the parabola doing on the left side of the vertex?
Going down.
Going down. What is it doing on the right side?
It's going up.
Okay, so it changes direction at that point, right? It bottoms out, it changes direction. We'll put that. Okay, axis of symmetry. Okay, when we see symmetry, what do we think?
Same.
Split in half. And so our axis is going to be what we split it in half. Could I fold that parabola onto itself?
Yes.
Okay, where would I fold it at?
The vertex.
0, 0. On the y-axis.
On the vertex. So in this case, it's going to be when x equals 0.
What is that thing? Did it say parabola?
Parabola. So, when x is 0 here, if this was my line, it folds and matches. Now you agree as I move the parabola around, that line may move, but I'm always going to have an axis of symmetry. We can also cheat whenever we want to draw a parabola. If we jump back to here, -1, +1 go to the same number. -2, +2 go to the same number. So really I could on this go down and just look at the list of all 1, 2, 3, 4, 5, 6, 7, and then the negatives of those would go to the same because it's the mirror image on the other side. You can get away with kind of drawing one side of the parabola from the vertex up, and then you mirror over across the axis to find the other ones, instead of finding the points. Again, you can do rotation. No, no rotation.
Can we get one of those pronunciation keys on parabola?
Good, you said it right. Domain. Have you seen domain before with functions?
Sounds familiar.
Yeah.
That's enough, isn't it?
Okay, it's going to be when x occurs. So what values of x work? Okay, so what I like thinking in domain is not thinking of which ones do work, which ones don't work. Is there any number that I could not plug in to get x squared? Okay, plug in 0. 0 squared 0. That works. Think of another number.
Negative.
5,000.
Oh.
5,000 squared. I could figure that out. Okay, there's any value that works. So I could put any number into the domain and it's going to fit. There's nothing that should be excluded. So when that works, when x occurs for all values, we just say all reals. So the domain is all reals, all real numbers. That's going to be all the time on a problem. Okay, so any value I can plug in. Range is different though. Range is usually your y values, or in this case your f of x values. It's which ones can occur. Now, on this graph, do I hit every possible y value? Where does it stop?
At the origin.
The origin. Can I have any y values down here? No. So in this graph, it's not all reals, as x is. I'm limited to anything that's 0 or greater. Right? Okay, so how are we going to say that? We said it was what type of numbers earlier? They were positives. They were
Negative.
so they're non-negatives in this case.
Wait, so isn't that the same thing as positive?
What's 0?
It's not
Non-negative.
Well, nothing.
That's our way of cheating around it. So if we say non-negatives, that means 0 and positive numbers.
See, 0 is the
If we say positives, it doesn't include 0.
0 is the vertex.
Okay, now for this case, we should also, we could say x is greater than or equal to, or not x, but y is greater than or equal to 0 would be our range.
Oh crap.
Okay, those values work when y is greater than or equal to 0. Now, what do you want to call that bottom value down here? When it bottoms out. It's the lowest point, right?
The origin.
Remember a word you saw yesterday?
Minimum.
Yes, the minimum. So we have a minimum here. That is when it bottoms out. So a minimum is when the graph will open up. It'll be that bottom point. Now, if we stood on our heads and looked at this graph or just flipped it over, and it was pointing down, what would we call this point?
The minimum.
Maximum. And what we're going to do is we're going to use the range. We're going to have that maximum or minimum help us figure out that value to relate them when we need to figure out those.
What would these actually be used for in like real life?
We will get to that. We have, and do you like cats?
Yeah.
Yeah.
Fantastic, even better for you. All right, let's start changing the graph. So, we kind of already did the x squared, so you don't need to copy the middle column in. I'm just going to put it in for reference. We're going to add a third column to this.
I love columns.
Okay, so now it's x squared. We now have 2x squared. So I've taken x squared, thrown a 2 out in front of it. Normally when we see the 2 in front, we think twice as big. How do you think it's going to change the graph of the one we originally had?
Gonna make it bigger.
Make it bigger. How?
The values will change. The values of x.
Do you think it's going to grow out to the side, or it's going to grow up?
Out and up?
So this is our original. This was f of x. Okay, let's go through and find some values. So, if I did 0 squared times 2.
0.
Still 0. Good. Let's start with 1. 1 squared times 2.
It's 2.
Okay. 2 squared times 2.
8.
Then we do negative 1 squared is 1 times 2. It's the same as the positive 1. So that means we're going to have what here? 8. All right, so our new graph starts at 0, 0. We go up 2, then up 8.
Oh.
2, up 8. So we sketch here.
It makes it steeper.
So this is now g of x.
So is it like the pattern you're doing right now? Like, I see the f of x equals 2x squared. That means x squared
Times 2.
times 2.
2 squared
4.
times 2 is 8.
Okay, yeah. Okay, thanks.
Or this, or it's really this value times 2.
So,
Because we took x squared
Oh, yeah.
multiplied by 2.
Yeah.
so the next one would be 16 and 4 and 0 and 4 and 16.
So you're saying if we did 4 here?
Yeah.
Okay, this is 4.
No.
What would x squared be?
Not enough.
You get another chance.
8.
4 squared.
8.
Try again.
16.
16.
You tricked me, Mr.
Which 2 times that?
32.
32.
You tricked me, you jerk.
Okay, so what did you like?
I always thought we were going to do like a fourth column.
We'll have a new column in a minute. Okay, but right now,
Excellent.
okay, I took x squared, I multiplied by a number bigger than 1 out in front of it, multiplied by 2, could multiply by 3, by 4, it stretches it up. Okay, still the vertex. Does it still have a minimum?
Yes.
Would the range be the same? Covers the same y values?
Yeah.
That doesn't go down here. Covers all the x values still. So, axis of symmetry, that's the other part. Same? All right, let's do another version. So now we're going to keep x squared, and we're going to do 1/2 x squared out in front. So the values we just did, if you just want to take your columns you have, like this, and just add another one on.
You should totally know.
-2, -1, 0, 1, 2. So we had these values earlier. You don't have to keep rewriting them. But let's now look at 1/2 x squared. So when we multiplied by 2, it stretched it up. What do you think the 1/2 is going to do?
Shrink it.
Divide.
Push it down, right? It's going to push down, make them half the value. So I could take these values, square them, divide by 2. But I already squared them here, so I'm just going to take half of these numbers.
Which means you could just take the x numbers, right?
Now, squaring something and taking half is a different thing.
Yeah, never mind. I didn't mean that.
That's a good question. All right, so here's our original. Okay, and then our new one is h of x. So we're still at 0, 0. We're going to go to the coordinate 1, 1/2. So over 1, up a half. We're going to go to the coordinate 2, 2. Over 2, up 2. Same on the other side because it's a mirror image. And it looks like this. So this is now h of x.
So the bigger the numbers, it's going to look more like a V.
Yeah, it flattens it. It's going to be flattening it down. So it presses it down, which actually now opens it up. Okay, what's another x value you want to plug in? Something we can graph here.
8.
8. I think 8 would be over here off the board.
3, 4.
There we go. Let's try 3. 3 and 4.
I have a question. How do you plug those answers into their life?
I took these numbers, I squared them, and took half of them. But since I already squared them here, I just took half of these numbers. It's the kind of that middle step. All right, so 3 squared is,
9.
and half of that is
3.
4.5.
4.5. Okay? 4 squared, and then half of that.
It's like 2 and a fourth. 2 and a fourth.
16.
2 and a fourth. Half of 2, 4.5 is 2 and a fourth.
8.
4 squared is,
16.
and half of that. Okay, if we look, we hit here at 3, 4.5, and then up here at 4, 8. Would it be the same points over here?
Yes.
Yeah, mirror image, it goes. So, what I want us to see here, now we take 1/2, and it starts to press it down, and it actually makes it look wider. Okay, that's because the values are pushed. Pushed down because we're taking fractions up. Vertex, axis of symmetry, range, domain, all of that still remains the same. But that number out in front changes the shape of the graph. Okay? Let's do something completely different. Let's throw a negative out in front. So now we got negative x squared. So we know we got 4, 1, 0, 1, 4, and 9. Okay. Here's x squared. We want negative x squared. That is different than squaring a negative. When we square a negative, we made it positive, because like negative 1 times negative 1 is positive 1. Right now, because it's on the outside, we're going to take whatever result we got here and change its sign to negative. So you square first, then make it negative.
So it's all the values of x, just negative.
Yep, exactly. So I go negative 4, negative 1, 0, negative 1, negative 4, and negative 9. So if our original graph looked like this, what does it do when we throw a negative out in front?
Taking it out this way? Oh.
Flipped it, right? Because we go negative 2, negative 4.
Wait.
Yeah. Order that we do it in. Right here I have negative 2 squared is negative 2 times negative 2, positive 4. Then we take the negative of that, becomes negative 4. So square it, which makes it positive automatically, then take the opposite. So this was our original function, now it's split down, it's facing down. So this is, down here, we wrote j of x, which was negative x squared. Okay? It's sad. It's a frowny face, because it's negative. This one's happy, it's a smiley face, because it's positive. Okay? The value you have in front is going to tell you which way it's going to face, up or down. Most of them open up. That's because most of the time we get a positive value out in front. Now if I stayed down here in negative, if I was in a continual bad mood, if I then made it negative 2x squared, it'd still be facing down, but what would the 2 change?
Did make it more steep?
And stretch it down like we had before. If I made it negative 1/2 x squared, it's going to press it down, it's going to open up. So as we change the shape of it by the number out in front, the negative also changes which way it faces. So our goal here is you get some function, x squared, with some value out in front. You need to understand which way it's facing and have an idea to when it's going to be wider or skinnier. We're going to get to looking at the actual equations and plotting the points, but right now we just need to have a general understanding and identifying what's happening. So, I got 5 parabolas here. What I want you to do, I want you to figure out what the vertex is. And does it open up, open down? So what is the A value? Is it positive or negative? Or you could just write whether it has a min or max. Vertex is
Negative 4, 5.
Right, -4, +5. Does it have a maximum or minimum? Maximum. That means
Yeah, Wayne.
the value out in front, if it was something x squared, would it be positive or negative? It's opening down.
It's negative.
Be a negative. So it's a maybe it's negative x squared. Maybe it's negative 2x. We don't know yet. We'll get to that later. But right now we at least have the idea it's negative. Okay? What about the axis of symmetry? I know I didn't ask for it, but we can actually pull that from what we already know. So the axis of symmetry.
It's negative 4.
Yeah, it's going to be when its x is -4. Because if we drew a line here to fold it, on the -4 is where it goes. Now, where else did we see -4 in what we've done so far?
C. And C.
The x value.
C.
Is the x value in the vertex the axis of symmetry?
Yeah.
Yeah, it will always be the axis of symmetry. So you can tell once you have the vertex what the axis of symmetry is. Okay, the range.
The range is
This is the y values that work.
5.
What is the biggest that y is going to be?
5.
It's going to be 5, okay. Is it going to be less than or greater than 5?
Less than.
Yeah, but it includes it, so we write y less than or equal to 5. So it's all the values below 5. Okay, let's go to B. Vertex.
4, 4.
Okay, does it have a max or min?
Minimum.
Minimum, okay. Axis of symmetry is when x is what?
4.
Good. And the range, our minimum value is what for y? Smallest it gets.
Y
4.
equal to.
Is it bigger or less
Greater than
than?
or equal to.
Greater than or equal to 4. All right, minimum. Axis of symmetry.
Negative.
Good, x equals -4. And our range,
Y is greater than or equal to -4.
very good. Okay, let's go to D.
2, 4. 2, negative 4.
To -4, which means our axis of symmetry is
2.
2.
good. And then our range is y going to be bigger
Greater than
or
or equal.
smaller?
Y is
Greater than or equal
Greater
to
than or
negative 4.
equal to.
-4. Good. Okay. Last one, E.
7. 3.
7, 3. All right. We know it opens down, so does it have a max or min?
Max.
Maximum. Good. Axis of symmetry?
7.
7. And range. It has to do with 3. It's going to be less than or bigger than 3.
Less than or
Y is
equal
less
to.
than.
Y is less than or equal to it. Right there, that's the stuff we got to pull from it. Now, that leads us to writing the equation. We'll worry about that next week. But if you can look at any of these parabolas and start to pick that stuff up, those are the key facts we have to start pulling. You have to know the vertex. But the nice thing, once you know the vertex, you know the axis of symmetry. It's the x value. You also know the min or max, or the value used in the range, because it's the y value. Look, 5, 5, -4, -4, 4, 4, -4, -4. So you get those from there, so all you then have to figure out is it the negative or positive. Does it open up or open down, less than or greater than? Okay, feeling good about that so far?
It's easy.
All he does.
Okay. Before we get to the cap, one more here. Now I have a 2 out there. What do you think it does to it?
It's gonna make it bigger.
So I'm going to bring in my same x values as before. Okay, so x squared plus 2 is what?
It's 4.
6.
Let's go -2 first. 6?
Oh yeah, 6.
Okay. -1 squared plus 2.
2. I mean 1.
3.
What?
Square it is +1. Add 2.
Plus 2.
Okay? Okay? 0 squared plus 2.
0, oh, 2.
1 squared plus 2.
3 and 6.
Okay? Again, it's a mirror image of the 2. Right? 2, 3, 6, 2, 3, 6. It reflected. Now, we go to graph it. Is that the graph?
Absolutely.
We even hit the points. We got 0, 2. We got 1, 3. And 2, 6. Okay? How did that change from the original one we had?
The parabola moved up.
1 times 0, 0. So what did the 2 end up doing to it?
It moved it up.
Yeah, it picked everything up and it said, you're going up 2. So if I have a value outside of the x squared, I basically squared it, added 2, that shifts everything up. Did the shape of the graph change from the original x squared?
No.
No, we just pushed it up that way. What if we made it negative 2?
Then it would push it down.
Yeah, everything would have moved down to there and it would be going off the negative value. So we could have a value out in front of x squared to change the shape. We could have the value on the outside that we add or subtract to it that moves it vertically. It moved the vertex. Did it move the axis of symmetry? Is it still the y-axis here?
Yep.
So the axis of symmetry. The range moved because the y value changed. And so little parts there, but everything moved. Yeah.
So if you only got one side of the number, you could just use reflection to put it on the other side, right? If it's on the line.
As long as it's on this axis, when we start moving it, it can be different, but we can also go back to, let's say I have a graph randomly right here. There's my vertex. And I know I go up 1 over 1, and then I'm right here. So I know at least that much. If I have an axis of symmetry, you just go to the other side, and you can mark the points on the other side to just match them over. So I don't even have to use that table. If I have part of it, I can match the other side. So it works. That's nicer to use on the graph instead of using the table. All right, so now we get our cat.
Yeah. What the heck is that?
Okay,
I forgot about it.
a cat is walking along a balcony. There's a potted plant there. The cat being,
Cat's name.
what do you want the cat?
Robert.
Jeffrey,
Fantastic.
no, Jeffrey.
Robert.
Bob the cat is walking on a balcony. He sees a potted plant. Being the friendly animal that it is, sees its enemy in the potted plant, decides to kick it off the balcony. That pot falls.
Does it hit anything?
It hits the ground.
What kind of plant is it?
And it's not only the fall that causes the pot to break, it's the sudden impact with the ground. The question is, how long does it take to hit the ground?
2 seconds.
No, it takes a long time.
Okay,
Okay, hang on.
I know.
Has the plant been recently watered?
It doesn't matter.
About how many leaves are on this
Objects
plant?
fall at the same time.
Stop talking.
Okay, we have
Faster, kind of breaks or kind of fails.
Have you done?
we have a function for falling objects.
Well, it falls faster. I found a paper. I found a bowling ball.
It uses negative 16x squared.
Bowling balls, but paper doesn't.
Okay, this is the quadratic function we use for a falling object.
Sure.
Okay, now we have to take into account how much that's shifted up. So what we need to do is look at where our potted plant is and treat that as a vertex.
We have to draw the cat.
If that's the vertex, we have to then extend it down to get our origin. So if it's 64 feet up, what do I have to add on to this to represent where our vertex is? 64, because that's how tall we are up. This is actually a flipped over parabola. Now with what we've already talked about,
You didn't say how tight they had to be.
with what we've already talked about, I have a negative there. It's facing down, right? really goes to the other side. We're not worried about how the potted plant got up there. We're worried about how it fell. Okay, so we have the negative there. 16. If we picture that graph, if we took x squared, that's stretching it out. And then 64 is we're starting up 64 feet up in the air. We're looking at for when it hits the ground. Do you agree it hits the ground at the x-axis?
Yes.
And that's what we're looking at. So we want to figure out time. In this equation, x is time. So, x is time. What would f of x represent?
The blue curve or the red
The y,
curve? Blue red curve.
Distance. F of X.
the y value?
The distance or the height? Does that work?
I guess so.
All right, so what do you think? What do you want to try? We want to figure out when f of x is 0. What do we have to plug into this to figure it out? So let's just pick a number to start. 3.
Why don't we just like drop a rock and time it?
So the way we write that
Make it a lot easier.
is we write f of 3,
Because I go find a rock.
because that means we put x in, put 3 in for x,
Time it rock.
is negative 16, 3 squared plus 64.
Off the balcony.
Drop a pencil and
Pay attention.
I'm paying attention. I'm arguing physics
Stop.
with Wayner.
Stop.
a line.
Okay? 3 squared is 9. 16 times 9 gives us what?
Remember, it's
16
negative
times 9.
16.
I only
That's negative 144 plus 64.
I always hated these.
So that means it's negative 80. So at that point,
We're in negative time.
Try 9.
Wait, does that mean we have negative time?
so that means at 3 seconds, it's 80 feet below the ground.
Oh.
So that took too long. If you were up in your balcony here and you saw the cat kick over your favorite potted plant, you're like, I'm going to run down the stairs. If it took you 3 seconds to get down there, you're too late. It's already broken.
I can run down 64 feet of stairs in 3
Okay.
seconds.
What else do you want to try?
9.
Okay, 3 seconds wasn't enough. Was too long.
How about 1.5?
1.
Okay, try 1.
2.5. 2.5.
So we got negative 16 times 1 plus 64. After 1 second, how high is it above the ground?
Negative 50 something. No, 40 something.
It's 0.
Oh, it's 48 feet above the ground. So at 1 second, how far did it fall?
No.
48 feet.
16 feet.
16 feet.
Okay, 1 second it fell 16 feet. So that was too little.
2.
Let's try 2. Why not?
Should have chose 2 words.
So negative 16 times 2 squared plus 64. What is 4 times 16?
64.
Oh, so now we got 0. So that means after 2 seconds, what is the height?
On the ground.
Yeah, 0. It hit the ground. So, our cat's up there, kicks our favorite potted plant. It starts falling, and at 2 seconds, it hits the ground. Okay? Now, what if the height was doubled? What if we were now...
Yeah, you would put 4 seconds.
Okay?
F of 4. Right?
So now the height is doubled. What would the height now be? 128. Okay? So it would now be f of x equals negative 16x plus 128. Okay? So if it's double the height, is it double the time?
Yes,
Yes.
4 seconds.
Well, let's find out. So that would be negative 16 times 4 squared plus 128. It means it's double the time if it comes out to be 0. Because we've doubled the height, so now if this works out and we get a 0, that means in 4 seconds from twice the height to hit the ground. Now, 4 squared is 16. 16 times 16 is 256.
Oh. Uh-oh.
That's incorrect.
Looks like we got negative 128. That means from double the height after 4 seconds, now you've run down almost 13 floors of stairs, or it's a really fast elevator. You're way too late. You're 128 feet too late. It hit the ground.
What if we didn't?
Why would it not work? Let's take a step back here. How far did it fall in 1 second? We've said right here.
48 feet.
No. 16.
60.
So in 1 second, it fell 16 feet.
Tries to.
Right? 1 second, 16 feet.
128 divided by 16.
Okay? In 2 seconds, how far did it fall?
32 feet.
That was the original answer. What was it?
64 feet.
64 feet.
Never mind.
In 3 seconds, we found that right here. We did 3 seconds, it was 144.
I see a pattern.
In 4 seconds, we just found that 256. The difference here is 48 feet. The difference here is 80 feet. The difference here is 112. Do you notice the further it falls, the faster it goes? Yeah, gravity accelerates as things fall. So even though it fell 16 feet in that first second, that second it went even more. That's going to happen when we look at a parabola. Because if we go back to look at the graph we originally started at, back here. Remember how I said it starts out level, or starts out slowly and speeds up? It's the same idea. This is the falling object. It started out falling slowly, but the further it went, the faster and the steeper it goes. That's what's going to happen with those parabolas. That's what happens when we look at a quadratic function.